All right, so I'm going to talk to you guys about how to read a very important curve called a solubility curve. However, before we get into that too much, we do need to touch back on the concept of saturation, which you guys did in preparing for the group quiz. I want you to imagine that you have four beakers here, and these four beakers are at different temperatures. And I want you to imagine too that for that one that's 0 degrees C, imagine that somehow I have prevented it from freezing solid. But then I want you to think about having a certain amount of a particular solute. And my favorite solute is always going to be NaCl here. And you have a very particular amount of NaCl. And I want you to imagine that you took this entire amount of NaCl right here, and you managed to put it all in to this beaker. And you were able to dissolve some of it. But in fact, when you went to dissolve some of it was left over. And you were able then to figure out how much, and I know it's a little more complex than this, but you were able to figure out how much was able to dissolve in 0 degrees C. Now the other thing that's going to be important here is that I fix the same amount of water in each one of these things. So let's just say this is, every single one of these things is 100 grams of water. Now if I were to do this, I would find that at 0 degrees C, I can dissolve about 33 grams of NaCl in 100 grams of water. And if I continued to do the same experiment, I would actually find that I could dissolve about 35 grams of NaCl in 20 degrees Celsius. And then I would keep doing this and collecting this information. And so you'd have a data set that would look something like that. Okay? So I know that I'm going to reach the point of saturation in, say, 40 degrees C, and I can't put in any more than 37 grams, dissolve in any more than 37 grams of NaCl. If I put in, say, 5 grams more, that 5 grams is just going to sit at the bottom of the beaker and not dissolve in no matter what I do. All right? Same thing here. If I put in a certain amount of grams, in this case 39, I know I've reached the point of saturation, and if I put in 39.1 grams, I'm going to have 0.1 grams that will not dissolve into the solution. And then the other thing that's important to notice here is that it increases with temperature. Notice that I go up by 2 every time I move up 20 degrees. And we shouldn't be surprised by that either, because we understand that when it comes to solids, an increase in temperature is going to increase the solubility of that particular solid in a given amount of water. So let's take a look then at other, actually let me go to this. Imagine if I were to then graph this information with the number of grams on the y-axis and the temperature on the x-axis. It would look something like this. So if I were to plot this, I would have around, say, 33 at 0, 35 at 4, at 20, etc. Something like that. And then if I were to draw a line, you would see it would look something like that. Well, that is the solubility curve for NaCl in 100 grams of water. And depending on the ionic compound that you were trying to dissolve into the water, the curve is going to look different. Some things are going to be more soluble, some things are going to be less soluble. And in fact, if we were to do this and graph a whole bunch of these ionic compounds on one set of curves, it would look something like this. Pretty cool, huh? Notice that some of these things are not linear. The relationship is not linear. So NaCl, we can see that's sort of what we just plotted moments ago. That's pretty linear, and sort of KCl and lead 2 nitrate and sodium nitrate. However, if we look at potassium nitrate, that actually increases in solubility at a much faster rate than you'd expect, right? So it's going to be an exponential relationship there. And same with calcium chloride, same with potassium chromate, etc., etc. All right. Interestingly, this dude right here, I have no idea what's happening here. I'm not even sure if cesium sulfate is a solid. but it appears to sort of not make a difference what the temperature is. In fact, hold on, I'm going to look into this. This is curious. Oh my goodness, that's totally cool. And by the way, it's not cesium, it's cerium sulfate. So apparently, cerium sulfate releases a ton of heat when it's dissolving. And you're not going to understand this yet, but you will. We're going to cover something called Le Chatelier's principle. And if heat is produced, that means it's one of the, it's going to be a product. And this is crazy, but as a result of it being a product, it's going to actually push the dissociation reaction back towards it reassociating and becoming a solid again. You're not going to understand that now, but just keep that in your brain as we move forward in this term in chemistry. Totally amazing. Anyway, the bottom line is you can look at this and see that for the most part, except for the cerium sulfate, that as you increase the temperature, you can increase the amount of ionic solid that you can dissolve in 100 grams of water. So that all makes sense. What if we take a look at this though from the perspective of gases? Then it should look a little bit different, right? And you can see here, this includes some of the same solids that we saw, but now I'm going to have us focus in on some things that are not solids. So hydrochloric acid, HCl. Now that may be strange to you because if it's hydrochloric acid, it's actually in an aqueous solution, but hydrochloric acid is actually a gas. And so that's what makes it hydrochloric acid when you bubble in the hydrogen chloride gas into the water to make the hydrochloric acid. And you can see that that is something where as you heat it up, it's actually going to become less soluble because it's a gas. It's going to percolate out and jump out of there. Same thing with ammonia, which is a gas that you couldn't keep in there as the temperature increases because it's going to aggregate into the actual gas form and lift out. And same here with the sulfate gas. So it all works. What we've been talking about in the group quiz and in class and in screencasts, if you were to actually perform any of these little studies and collect the data, you would indeed find that the solubility of a gas decreases with temperature and the solubility of an ionic solid increases with an increase in temperature. So there you have it. That's your solubility curve. Totally cool and useful information, at least from my perspective. Bye.